Well, hello and welcome to this exercise in which we look at the geometry of trapezium, and this will also include trig and some calculus. Now, this is an additional mathematics question, so in effect this is a revision exercise. Now, the first one says, using an equilateral triangle of side 2 units, find the exact value of sine 60 degrees and of cos 60 degrees. For part B, now we've got this trapezium and it says PQRS is a trapezium in which PQ is equal to RS is equal to X centimeters and QR is equal to Y centimeters. Now angle QPS is equal to angle RSP is equal to 60 degrees and QR is parallel to PS. It then says, given that the perimeter of the trapezium is 60 centimeters, express Y in terms of X. Secondly, given that the area of the trapezium is a centimeter squared, show that A is equal to the square root of 3 multiplied by 30x minus x squared, all divided by 2. And lastly, it says, given that x can vary, find the value of x for which A has a stationary value and determine the nature of this stationary value. Okay, now to begin with, for this exercise, the number 2 occurs quite a bit. So you got to be very careful that you have the right 2 in the right place or you get the answer wrong. Okay, now I'm going to start with A there. Now to do that, I'm going to draw an equilateral triangle. I have to excuse my drawing. Freehand as this is. Okay, and that point is A. Now I'm going to drop a line from A to the base of this triangle such that this angle is 90 degrees. Now if that angle is 90 degrees, this line H will bisect the base. So in effect, that's 1 and that's 1. And because this is an equilateral triangle, that's 2 as well. And that angle there is 60 degrees. So that's 60 degrees there. Okay. Now, firstly, we need to find the value of H. Now, H is equal to the square root of 2 squared minus 1 squared. And the answer we get is that H is equal to the square root of 3. Okay, so H is root 3. Now, the sine of 60 from this diagram here, the sine of 60 will be H divided by 2. And we know that H is root 3, so the sine of 60 is root 3 divided by 2. Similarly, the cosine of 60 is going to be the adjacent divided by the hypotenuse, and the adjacent in this case is 1. So in effect, cos 60 would have been 1 divided by 2. And that's the answer I require for the first part. And for that, you get 3 marks. Okay? So our answer will then be that sine 60 is root 3 over 2, and the cosine 60 is cos 3, is a half 1 over 2. Now, for B, we need to drop a line. Sorry, that my height has shifted. Drop a line from the point Q to the base of the trapezium PS there. And we call that line H. So that's the height because that's 90 degrees there. Okay, that's 90 degrees. So that's the height of the trapezium. Similarly, we can drop a line from R to the base PS. Again, that is the height of the trapezium. Now, if we call that line there A, and you find that these two triangles are similar and congruent because you've got 60 degrees, 60 degrees, 90 degrees, 90 degrees, and the edges are the same. So that line there is also A. Now, we are not in a position to do this bit here. So, A over x is cos 60 because adjacent divided by hypotenuse is the cos. A over x is cos 60, and we know that cos 60 is a half. So A is equal to a half x. And because you got two A's there, that one and that one, now 2A will then be x. Right. Now, we are told that the perimeter is 60, so which means that the perimeter is also 2y plus x, or 2x if you like. Now, plus the two little ones, and this A and the A there. And we know that the two A's will give us x. So 60 is equal to y plus 2x plus x. So 2y then becomes 60 minus 3x. If we then divide both sides by 2, we end up with y is equal to 60 minus 3x divided by 2. And that's the answer required for B part 1. Okay. Now, moving on to B part 2, we are told that we want to find A in terms of x. So what you then do is this here. Now, the area of a trapezium is the height divided by, multiplied by half the sum of the parallel sides. Now, we know that the parallel sides will be 2y because that's y, and that's y, plus the two A's there and there. Okay? So the area will be 60 minus 3x because that's 2y there, plus x divided by 2. Now, h there will be x times root 3 over 2. That one there. H, if you divide h by x, you get sine 60, and sine 60 is root 3 over 2. So h is equal to x multiplied by sine 60, and sine 60 is root 3 over 2. So that bit there is our h there. Okay? So now, if you divide 60 by 2, you get 30. If you divide minus 3x plus x, give us 2 minus 2x. If you divide minus 2x by 2, you get minus x. So this here is the area of the triangle. Now I'm going to copy that down again. And now if we multiply 30 and x by x, we get root 3 over 2, 30x minus x squared. And that is what's required for this bit there. Okay, moving on. For the last part, we want to find where the turning point is. And to do that, if we say that a is equal to root 3 over 2 multiplied by 30x minus x squared, if we then differentiate a with respect to x, we have that. Now at the turning point, we're going to equate this to 0. So if we then say root 3 over 2 multiplied by 30 minus 2x, is equal to 0, and that gives us a value of 2x is equal to 30, in which case x is 15. So that is the answer we require for the first part of the of B3 there. Okay, now to find out if at this point whether x is equal to 15 is the maximum or minimum point, I'm going to take a second derivative of a. So we now have that d2a divided by dx squared is equal to minus 2. And because we have minus 2 there, that suggests to us that the turning point is a maximum when x is 15. Okay, so that now is the answer we require for this bit there. Now, just to check, if we draw a graph of a against x there, we should end up with a graph that looks like this one there, which confirms our result that at the turning point x is 15. Now, I hope all that made some sense, and please subscribe. Thank you for watching, and please watch some more of my videos. See you again sometime, and bye bye now. Bye bye.